Okay, so for the chapter review for Pearson, chapter 3, question 19, the last question is a mobile question. So I'm just going to draw that out for you now. What you've got is a rigid body. It's going to have a center of mass coming down. And either side, on one side you have the sun, which is exerting a force downwards, and on the other side you have the earth, which is not as much of a, not as high as a force. And then to attach this rigid body to a ceiling, you're going to have a bit of string that's probably going to attach somewhere around there. And the question's asking you, what is the distance between where the string attaches and the sun? And it's asking to give that answer in centimeters. So the first thing I want to do is I want to pick a pivot point, and that's probably the hardest part. I know that we don't have the value of this tension, so we might be inclined to pick this point, but I know this is going to make it more complicated. Doesn't mean you can't do it, but for simplicity's sake, instead, what I'm going to do is I'm going to take this here as a pivot point. So about this location, I can expect to have, just write it out correctly, equal to the sum of all the clockwise torques. I'm going to have RT, where T is the tension in this string. It's going to be equal to RF plus RF, because it's all acting perpendicular to make it nice and easy. And this is the string. And this here is the center of mass. And this here is the earth. So the one thing I don't have is that tension, but I know that all the upward forces have to equal the downward forces. So I know that this is 0.145 kilograms. I know this is 0.01 kilograms, and I know this is 0.0225 kilograms. So to work out the tension, that's just going to be mg. So it's going to oppose all of these downward forces, right? So it's going to be 9.8 multiplied by all of those masses added together. 145 plus 0.01 plus 0.0225. And what I should get is 1.7395 newtons. So that is the tension in the string. Okay, so now that I have all the information about these three things that are factoring in the torques, I can go back to my, to this equation here. So I'm just going to restart this bit and bring it back down. So what I have now is I have R, and then in small, and in brackets we have the, what was the number? 1.7395. And for the center of mass, so the distance from the pivot is going to be 0.05. Sorry, 0.5. It's halfway along, it's 1 meter long. Times 9.8 times, and the mass of that is 0.01. And now the earth side, which I know is 1 times 9.8 times 0.0025. So now that I know that, I can keep going through, and I'm going to have 1.7395R is equal to, what I end up getting is 0.2695. So R is going to be 0.2695 over 1.7395, and that's going to be 0.155. And the answer is asking for it in centimeters, so it'll be 15.5 centimeters from the sun. And there we go.